So now let's look at an example involving crystallographic points. So this one will be in your quiz. So I've got an image here, and I've got the label for point A as the red circle here. So this is point A, and then I also want you to draw a point as well. So what I want you to do, the first thing I want you to do is determine the point coordinates for A, just like we did with the body center position in the previous module. And then draw a point B into this unit cell at the point coordinates of 3/4, 1/2, and 1. So go to the quiz, answer those questions that you'll have, pause the video, and then I'll come back and we'll go through both of these questions in more detail. All right, so let's look at where point A is and determine the point coordinates. So if you need a better view of this, I sketched this from the slide, but you can go back and look at that. So we want to determine where this point is. The little figure around the point kind of helps you to indicate where it is. But let me sort of see if I can help you out with that by looking at some two-dimensional shapes. So if I just look from the top down, right? And so I have the x-axis, and I have, this is the x, y, and z. So let's just say I'm looking at x and y, and then upwards is z. So I just have a square, right? And I have atoms on the corners. So the point that I'm talking about here is in the front top portion here. And so if we kind of divide this into fourths, effectively this is right in the middle, if that makes sense. So it's right in the middle of that because I have an atom here that corresponds to this, and I have the corner one that corresponds to this. So it's right basically at this point if you look down from the unit cell here. If I look on the side, so let's say that I'm looking basically just at that face. So in this case, my this is the y, this is the z, and then this is the x coming out at me. And I look at that cube to, again, identify where it is. It is in the top. So again, if I divide it into fours again, it's basically in the top corner here, right in the middle of this square. So now let's go through the process of point. So I just drew these out, because sometimes it's a little hard to visualize, and that's one of the skills that will be helpful as you look at these three-dimensional models, is where are particular points. And so I often find it is helpful to draw different two dimensions so that you can see it. So let's look at where it is in terms of the x direction, right? The fractional amount. So in the x direction, and so this one is a good one to look at because we can look at the x direction here, right? So this is half, so this would be 3/4, right? So it's actually 3/4. So basically this distance, right, is 3/4 of A. 3/4 of the A length. All right, and then for y, in the y direction, we can again use this diagram, and we see that if we go along the y direction, which is, this is length B, it's here, and that's 1/4, right? This 1/4 B is this fragment, just a small fragment. So 1/4 B. And then to look at the z-axis, we can't really use this one, but we could use this one because the z-axis goes up here from the origin here up. And so this distance is going to, again, be that 3/4, but of C. So Z we have 3/4 again of the C direction. So when we write this, again, we don't use A, B, and C, and we don't put any commas or anything like that. So we would just write point A as 3/4, 1/4, and then 3/4. That is the point coordinate for A. All right, so for point B, let's go ahead and start with the new one. So I've redrawn a unit cell, and it wants me to draw point B, which is, they give us the coordinates as 3/4, 1/2, and 1, right? So I'm going to do it the same way, but kind of in reverse, right? So I know that this is along the this is along the x-axis, 3/4 of the length A. This is 1/2 along the y-axis, and then this is the full length of the z-axis, or C. And so I can start with the origin and travel 3/4 of the length, right? Because I know this whole thing is A. So 3/4, and you can kind of approximate. It's going to be hard to tell, but if you're in doubt, I would label it. So you could label this as 3/4, right? So basically, after the first position, I'm there, right? But that's not the point, because we still have to use the other two coordinates. So from this point, I also need to travel 1/2 the length of the y-axis. So that's along this direction. So I go 1/2, and that puts me somewhere right here, which is half the length of the y-axis. So after the second step, I'm right here. Again, that's not the full point. We still need to travel one length of C, which is this, right? This is C, and then this length here is the B that we just talked about. So I need to travel all the way up and go one length, and so that's going to put me somewhere right around here. And because it's a whole length, we're going from, if you think about it, we're in this bottom face, so one unit would put us in the top face, and so we're going to be basically on this top face of the volume, and it's going to be 3/4 along this direction and 1/2 along, this is 1/2, and then 1 unit up. So my point is right here. This is point B. And so when you do these types of sketches where you show a point or other features, it can be kind of difficult to tell where this point is without some work shown. So make sure that when you're doing this, make sure that you show your work so that we can tell where this point is, right? Because you could have just put a point down, right? I don't know where this point is. Is it on this face? Is it in the middle? We don't know. So make sure that you kind of show your work with your fractions. So you can put your fractions up here. You can show the work as you kind of go along, but you do need to show your work so we can tell that you have the correct point. So that's how we draw or sketch a point based off of the coordinates.